Okay, so here question is a steel wire 2 millimeter in diameter is stretched between two clamps. So basically, what is the type of question? A rod is there, a steel wire or rod is there in between two clamps like this. Okay, now at 40 degrees centigrade there is no tension. At 40 degrees centigrade, when the temperature is like 40 degrees centigrade, there is no tension. Calculate the tension in the wire when its temperature falls to 30 degrees centigrade. So what will happen? Basically, when you are when temperature is decreasing, means length of the wire is also decreasing. So at that situation, because these two clamps are fixed, so there will be some tension at the wire, okay, because of length contraction. Now we have to find out the tension. This tension we need to find out. Okay, this tension I am denoting it as T. Now temperature can also be denoted as theta. Okay, no problem. Now initially its length was same. Like I am considering that initial length was L. So what is the change in length? So delta L is equals to L alpha delta theta, या delta t, delta theta I am writing. So L is the original length. So basically delta L by L, from here we can easily find out delta L by L is equals to alpha into delta theta. What is the value of alpha for steel? That is 1.1 into 10 to the power minus 6. So 1.1 into 10 to the power minus 6 into per degree centigrade it is given, right? So no need to change the unit. Even we are taking the change in temperature, so no need to change. So basically from 40 degree to 30 degree we are changing, and we are not keep putting final minus initial. You can put, no problem, their answer will be negative, like 30 minus 40 will be minus 10. No problem, you can put to get the length contraction, but I need only value. Okay, so this is why I am putting means capital minus small. So 1.1 into 10 to the power minus 6 into 10. So 1.1 into 10 to the power minus 5. And this delta L by L is the change in length by actual length. From the concept of mechanical properties of solid, the name of this thing is what? What was that thing? Strain, right? Longitudinal strain, delta L by L. Remember that, solid state physics. Okay, so delta L by L is equals to 1.1 into 10 to the power minus 5. Now some gamma is given. Why gamma is given? Why Young's modulus is given? Because we need to find out the tension, na? So this is why it is given. So what is the formula for y? Y is equals to simply force by area divided by delta L by L. Okay, now if you put all the values, then you will get force. This force is basically the tension, so we need this F only. So what is the value of F? F is equals to y a delta L by L. Now put all the values, like y still is 21 into 10 to the power 11. A means area, cross sectional area is the, see, it is in diameter. Steel wire of diameter 2 millimeter, right? So what is the area? What is the value of area? So area is simply pi r square, that means pi d square by 4 in the form of diameter. Pi r square, r means d by 2, so d square by 4, so pi d square by 4. Now 1 pi by 4 into d square, it is in millimeter unit. Need to remember, it is in millimeter unit. So basically 2 millimeter means 2 into 10 to the power minus 3 meter whole square. So 4 will cancel because 2 square is 4, and finally we'll get area is pi into 10 to the power minus 6, this much. Now if we put here, so this much was the Young's modulus y. A means pi into 10 to the power minus 6, and delta L by L is how much? That is 1.1 into 10 to the power minus 5. 1.1 into 10 to the power minus 5. Now this minus 6, minus 5 and 11, you can cancel because minus 5 minus 6 is minus 11. So finally we are getting 21 into pi means 22 by 7 into 1.1. 7 3 is 21. So what we are getting? 3 into 22 is 66, right? 3 into 22 is 66. So 66 into 1.1, right? 66 into 1.1. How much is the answer? 66. So 6, 2, and 7. So 72.6 is the correct answer. 72.6. 1 minute. For y was in dyne per centimeter unit. Just a second. I have made a mistake. What kind of mistake? It was in sorry. So we have to convert it in SI system, na. We have made a mistake. So basically what it will be, 21 into 10 to the power 11. Dyne means 10 to the power minus 5 in Newton, and per centimeter square, that means 10 to the power minus 4. So basically we'll get 2.1 into 10 to the power 11. Okay, 2.1. So nothing that much change, not that much change will not be here. So 2.1 means one decimal place only switch. So 6.6 into 1.1. So answer will be 7.26. Answer will be 7.26. Yes, 7.26, this much in meter unit. Sorry, in Newton unit, because we are finding the tension, na? So in the 7.26 Newton. So once just check the calculation part and means confirm the answer. Okay, I hope 7.26. Okay, I hope you have no doubt in this portion. So basically you have to deal with the units carefully. Obviously this is the physics, means the difference between physics math is this one, that the unit we have to need means deal carefully. Here it was in CGS system, na, so take it. Okay, thank you.